The solar system once seemed simple, a neat and tidy arrangement. 9 planets, each in their prescribed orbit, dutifully circling our sun. It was a comforting image of cosmic order. Mercury, the swift messenger, Venus veiled in mystery, and Earth, our vibrant home, Mars, the rusty wanderer, Jupiter, the giant with its swirling storms, and Saturn adorned with its majestic rings, Uranus tilted on its side, Neptune, a deep blue world, and of course Pluto. Pluto was always the smallest and farthest, a distant and enigmatic world. It was the underdog at the edge of everything we knew, a lonely sentinel guarding the fringes of our solar system. We loved it for its tenacity and mystery, for its sheer will to exist in the cold dark void. It was a familiar name in our cosmic family, a cherished member of our planetary neighborhood. But in 2006, everything changed. Science, in its relentless pursuit of truth, updated its understanding of the cosmos. The International Astronomical Union, the governing body of planetary definitions, gathered. They convened to answer a fundamental question, a question that would reshape our understanding of the solar system. What exactly a planet? Their new, more precise definition, based on new data and observations, ultimately left Pluto out. Suddenly, our solar system, so familiar and comforting, had only 8 planets. Pluto was reclassified, relegated to the category of a dwarf planet. This sparked public outcry, a wave of nostalgia and protest. But this wasn't about shrinking our cosmic neighborhood or diminishing Pluto's importance. It was about scientific honesty, about refining our understanding of the universe based on the best available evidence. Pluto wasn't being kicked out of the solar system, banished to some cosmic wasteland. It was being properly sorted, placed into a category that more accurately reflected its characteristics and its place in the solar system. The demotion, as some called it, revealed a profound truth about our solar system. The outer solar system is not an empty void, but a bustling region teeming with celestial bodies. It's filled with thousands of icy bodies, remnants from the formation of the solar system. And within this realm, Pluto became the king, the most prominent member. It became the leader of a previously unknown kingdom, a realm of dwarf planets and icy objects. The story of Pluto is not one of loss or diminishment. It's a story of discovery, of expanding our understanding of the universe. It's a reminder that science constantly refines its definitions, that our knowledge is always evolving. It does so as new evidence comes to light, as we peer deeper into the cosmos. The universe doesn't care about our categories or attachments, about what we call things. It simply is, a vast and awe-inspiring expanse full of wonders beyond our wildest imaginations. Pluto's reclassification opened our eyes to the vast and mysterious Kuiper Belt. It showed us that our solar system is still full of secrets, waiting to be uncovered. Before the great debate, before the controversy, Pluto was just a ghost, a theoretical planet X, a celestial body suspected to exist because of odd, unexplained wobbles in the orbits of Uranus and Neptune. These deviations hinted at a hidden gravitational influence. For years, astronomers tirelessly scanned the heavens, until Clyde Tombaugh in 1930, meticulously comparing photographic plates, found a faint moving dot lurking in the constellation Gemini. The world erupted in celebration, hailing the discovery of the 9th planet in our solar system. An 11-year-old girl from Oxford, England, Venetia Burney, with a keen interest in classical mythology, suggested the name Pluto, a name perfectly fitting for a world shrouded in perpetual twilight, far from the warmth of the sun. Pluto is undeniably tiny, significantly smaller than our own moon, a mere fraction of its size, orbiting at an immense distance, nearly 6 billion kilometers from the sun, in the frigid outer reaches of our solar system. For decades, even with the advancements in telescope technology, our best images showed only a fuzzy, indistinct blob. We knew it was undeniably small, primarily composed of ice, and possessed a strange, highly tilted orbit, setting it apart from the other planets. For 20 years of its incredibly long 248-year journey around the Sun, Pluto actually ventures closer to the Sun than Neptune, temporarily becoming the 8th planet. It even boasts a thin, tenuous nitrogen atmosphere that freezes and falls as snow onto its surface when it's at its farthest point from the Sun. Then, in 1978, astronomers made another groundbreaking discovery: Pluto's large moon, Charon, a moon so big, nearly half the size of Pluto itself, that the two celestial bodies form a binary system, tidally locked, and always presenting the same face to each other. Just imagine looking up from the surface of Pluto and witnessing a huge, unmoving moon dominating the sky. This was the extent of our knowledge about Pluto for most of the 20th century, a tiny, frozen double world residing at the very edge of our planetary system, a cosmic oddity. Its secrets remained largely hidden, tantalizingly out of reach, waiting for a much closer, more revealing look. Pluto was, and in many ways still is, a mystery, a distant speck of light that captured our collective imagination and fueled our desire to explore the unknown. Once considered the ninth planet, Pluto underwent a significant change in status. Why did Pluto lose its planetary status? A decision that sparked considerable debate and discussion within the scientific community and among the public. The answer lies in the discovery of new worlds, and a deeper understanding of our solar system's outer reaches. In the 1990s and 2000s, astronomers, using increasingly powerful telescopes, found other large objects lurking in Pluto's neighborhood. These discoveries began to challenge our traditional definition of what constitutes a planet. These objects resided in what we now know as the Kuiper Belt. In 2005, Mike Brown's team made a groundbreaking discovery: Eris, a celestial body even more massive than Pluto. This discovery intensified the debate. If Pluto was a planet, shouldn't Eris be one too? The question forced astronomers to confront the very definition of a planet. Suddenly, we faced the prospect of dozens of planets, potentially hundreds, as more Kuiper Belt objects were discovered and characterized. To resolve this dilemma, the International Astronomical Union, the authority on planetary nomenclature, convened and set 3 rules for planethood. First, it must orbit the Sun, as opposed to orbiting another planet. Pluto passes this first test. Second, it must be round, or more accurately nearly round, shaped by its own gravity into a state of hydrostatic equilibrium. Pluto also passes this criterion. Third, and this is the crucial one, it must have cleared its orbital neighborhood of other objects, becoming the dominant gravitational force in its zone. Here's where Pluto fails to meet the requirements. It shares its space with countless icy bodies, asteroids, and other debris in the Kuiper Belt. Pluto is the biggest fish in a crowded pond, but not dominant enough to have cleared its orbital path. Because it hasn't cleared its orbit, Pluto was reclassified in 2006 as a dwarf planet, joining the ranks of other similar objects. This new definition, though controversial, brought clarity and made sense of our increasingly crowded solar system, providing a framework for understanding the diverse range of celestial bodies within it. Pluto's demotion wasn't a loss. It was a sign of how much more we had to learn, and how our understanding of the universe is constantly evolving. The Kuiper Belt turned out to be a vast, dynamic region teeming with icy worlds and complex interactions, not an empty void as previously imagined. Our understanding of planets, and the solar system as a whole, had to evolve to accommodate these new discoveries, and a more nuanced view of our cosmic neighborhood. Pluto's story is a lesson in how science adapts to new discoveries, challenging existing paradigms and pushing the boundaries of our knowledge. For decades, Pluto was a blurry dot, a mystery. In 2015, NASA's New Horizons spacecraft changed everything, flying past Pluto after a 9-year journey. What it revealed was breathtaking. Pluto is vibrant, complex, and geologically active. The most iconic feature is a vast heart-shaped plain, Tombaugh Regio. Its western lobe, Sputnik Planitia, is a glacier of frozen nitrogen, methane, and carbon monoxide, churning in slow-motion currents. This activity hints at an internal heat source stunning for such a distant world. Pluto's landscape is diverse: mountains of water ice, vast plains, deep canyons, and strange bladed terrain. Nitrogen ice glaciers flow down mountains, carving valleys. Pluto's thin blue atmosphere forms a hazy ring, created by sunlight breaking down methane. The images from New Horizons transform Pluto from a distant dot into a world of beauty and activity. Pluto, once thought inert, is alive with surprises. To appreciate Pluto, compare it to Earth. If Earth were a basketball, Pluto would be a golf ball. Pluto's diameter is less than the distance from New York to Denver. Its gravity is so weak you'd weigh just a fraction of your Earth weight, leaping high with ease. Pluto's feeble gravity can't hold a thick atmosphere, gases escape easily. A day on Pluto lasts 6.4 Earth days, 3 days of daylight, 3 of darkness. A year on Pluto, 248 Earth years. Since its discovery, it hasn't completed half an orbit. The Sun on Pluto is just a bright star, giving 1,000 times less light than on Earth. High noon is like deep twilight, and temperatures hover around -230 degrees Celsius. Pluto is a world of profound cold and dim light, a stark contrast to our warm, bustling Earth. Its alien cycles and environment remind us how unique our home is. Yet Pluto's differences make it all the more fascinating. Pluto isn't alone. Its reclassification revealed a family of dwarf planets in the solar system's far reaches. Eris, discovered in 2005, is slightly smaller but more massive than Pluto, covered in frozen methane, and orbits twice as far from the Sun. Eris has a moon, dysnomia, and stirred up the astronomical community. Haumea stands out for its fast rotation, giving it a stretched football shape, 2 moons, and a faint ring. Makemake, slightly smaller than Pluto, has a reddish color from organic molecules called tholins. Makemake was nicknamed Easter Bunny, before its official name. Ceres, the first dwarf planet visited by a spacecraft, is different. It lives in the asteroid belt between Mars and Jupiter. These worlds show the diversity of our solar system's inhabitants. The Kuiper Belt is a rich, populated region, not an empty frontier. Studying these cousins helps us understand the solar system's true complexity. How do we study worlds billions of kilometers away, mere pinpricks in our telescopes? Astronomers use clever techniques, like spectroscopy, which reveals surface composition by analyzing light, and stellar occultations, which measure size and atmosphere as a dwarf planet passes in front of a star. These methods told us about Pluto's exotic ices and thin atmosphere long before we saw it up close. But nothing beats going there. Robotic missions like New Horizons and Dawn have transformed points of light into real places. New Horizons gave us more data on Pluto in hours than we'd gathered in 85 years. These missions change our view of the solar system forever. Each new image brings distant worlds into focus. New Horizons raised a tantalizing idea. Pluto might have a hidden ocean beneath its icy shell. Despite the cold, radioactive decay in Pluto's core could generate enough heat to keep water liquid deep underground. Evidence of recent geological activity, like flowing glaciers, supports this. If Pluto retains enough heat, a subsurface ocean could exist, insulated by ice and kept liquid by ammonia or other antifreeze compounds. Sputnik Planitia's gravity hints at denser material, possibly liquid water beneath the surface. Cracks and faults may show the crust expanding as the ocean slowly freezes. If true, Pluto joins other ocean worlds, expanding our idea of where life might exist. Even in the coldest places, the ingredients for life could be hiding. Pluto's journey, from discovery to planet to dwarf planet to New Horizons revelations, has made it a symbol of exploration. It marks the frontier between the known and unknown. Its demotion didn't diminish its importance. It expanded our map, revealing a vast new region of icy worlds. Pluto forced us to rethink what a planet is, and opened our eyes to the richness of the outer solar system. The Kuiper Belt is now a third zone, full of time capsules from the solar system's birth. Pluto is not an outcast but an ambassador to this new realm. Its story is a lesson in the scientific method. Science adapts as new evidence emerges. Pluto's reclassification was science correcting itself, not a mistake. The images from New Horizons reignited our sense of wonder. Exploration is fundamental to the human spirit. There are always new worlds to discover. Pluto challenges us to keep looking up and pushing boundaries. The universe is vast, and Pluto, the small world with the big heart, invites us to explore.